All right, number 20 asks us to find all solutions on the interval from 0 to 2 pi for this equation. Sine squared theta minus 1 equals cosine squared theta. So there's a few ways that we could do this. We could use our power reducing identities and replace sine and cosine with these. We could move this sine over to the other side. We get cosine squared minus sine squared and use our double angle identity that says that cosine of 2 theta is equal to cosine squared minus sine squared. But I actually want to solve this one with just our basic Pythagorean identity. Let's take this sine squared and let's replace that with 1 minus cosine squared. So take this sine squared and we're going to replace that with 1 minus cosine squared theta. Then we've got minus 1 equals cosine squared theta. So now we've got a 1 minus 1. Those are going to subtract to 0. And we get cosine squared, or negative cosine squared theta is equal to cosine squared theta. So now, one thing that I want to point out here, don't divide both sides by cosine squared. That's gonna mess things up because there's a good chance that that the solutions we're looking for, or some of the solutions we're looking for at least, happen when cosine theta is equal to 0. And so if you do that, then you're dividing both sides by 0, and that's wrong on many levels. So what we want to do here is let's add cosine squared to both sides. And so this will become 0. And on the other side, we get 2 cosine squared theta. All right, so at this point, let's go through the algebra. But we can see that cosine is going to equal 0, right? We can divide both sides by 2. We still get cosine squared theta is equal to 0. We can take the square root of both sides. We get cosine theta equals 0. And we can leave off the plus or minus because in this one case only, because 0 is neither positive nor negative. And so now we just look for the places where cosine is going to be negative. So where cosine is going to be 0. And cosine is going to be 0 where your angle is either, if we look on our unit circle, cosine is 0 up here and down here. That's at this angle, pi over 2. And at this angle, all the way around, at 3 pi over 2. And those are our two solutions for this problem.